Now we are discussing another type of pericyclic reaction, that is cycloaddition reaction. What happened here in cycloaddition reaction? Here two pi systems, means we need two molecules with pi bond, undergo this reaction to form cyclic product. So we get always here a cyclic product. So there are again two types of cycloaddition reaction. First is 2 plus 2 cycloaddition reaction, or 2 pi plus 2 pi cycloaddition reaction. Why it is called 2 pi? Because there are two molecules I have taken of ethylene. In one molecule there is a 2 pi bonds, 2 pi electrons, and in another molecule, the same molecule repeated here, having 2 pi electrons. So because of this 2 pi and 2 pi electron, it is called 2 pi plus 2 pi cycloaddition reaction. What happened here? I have shown here the moment of the bond. This bond is going in between 1 and 1, and this bond is going between 2 and 2. So as usual, you can draw the cyclic transition state. These bonds are being broken and these bonds are being formed, that I have shown with the help of dotted line. So this is transition state whose potential energy is more. So this is transition state, and you can see this is cyclic transition state. This cyclic transition state is converted to the cyclobutane. This is converted to the cyclobutane. Now see, there are two sigma bonds. So these 2 pi bonds are converted to the 2 sigma bonds. Here another example, and that example is 4 pi plus 2 pi cycloaddition reaction. But before I discuss this 4 pi plus 2 pi cycloaddition reaction, I want to clear one thing, that 2 plus 2 cycloaddition reaction is always photochemical reaction. So if you want to perform 2 plus 2 cycloaddition, you have to use light. Otherwise there will be no reaction. And 4 plus 2 cycloaddition reaction is always thermal reaction. That's why I have shown here the thermal heat energy. So in thermal reaction, what happened? There are two bonds, 2 pi bonds. 2 pi bond means 4 pi electrons. So 4 pi electron plus 2 pi electrons from this molecule ethylene and butadiene. Total 4 plus 2 pi electrons, and that is addition reaction. That's why it is called 4 plus 2 cycloaddition reaction. Again I have shown the moment. This bond is moving in between 1 and 1, and this bond is moving in between 4 and 2. So this reaction, this transition state is formed, and this transition state is converted to the cyclohexene. So here in 4 plus 2 cycloaddition reaction, we always get 6-membered ring. We always get 6-membered ring. That you must remember. And in 2 plus 2 cycloaddition, we get here 4-membered ring. So again, I want to add one more reaction which is always studied under the heading cycloaddition reaction, and it's very popular reaction. The name of that reaction is a Diels-Alder reaction. Diels-Alder reaction. So what is this reaction that we are going to discuss now? It is again, Diels-Alder reaction is nothing but the 4 plus 2 cycloaddition reaction. Is nothing but the 4 plus 2 cycloaddition reaction. So here we require a diene. So here always we require a diene. Actually I have taken here 1,3-butadiene, but you can add anything here. You can use different substituents, but you need a 4 pi system, that is diene, along with a 2 pi system. In this reaction, this is called Diinophile. This is called Diinophile. The reaction is performed in presence of heat. So this is moving here in between these 2 carbons, and this bond is moving here in between these 2 carbon, and this bond is changing its position. So in this reaction, again in Diels-Alder reaction, there is always formation of 6-membered ring. So you remember 6-membered ring, cyclohexene here, cyclohexene, 6-membered ring. You don't forget that there is always formation of 6-membered ring. You don't forget, this is 6-membered ring. So you are adding diene with the Diinophile, and you are getting, yes, a 6-membered ring through the cyclic transition state. That's why it's cycloaddition reaction. I put here a few examples. I'll keep that diene constant and I'll change dienophile. Suppose I add here the substituent. This is acrylonitrile. Acrylonitrile. So what is the product? Acrylonitrile, again moment of bond. You just shuffle all these bonds and form this 6-membered ring. This bond is lying here now in between these two carbons, and this is this fragment. This is this fragment. So cyanide is there. So you are getting this product. Again, you can change this dienophile. You can change this dienophile. This anhydride I'm using, this is again dienophile. Whatever structure is given here, don't worry. You have to focus on this carbon-carbon double bond only. And then this bond is moving here, this bond is moving here, and this bond is moving here. And you draw, your attention should be on 6-membered ring. You try to draw that 6-membered ring. This is sigma skeleton. And now this bond is moving. So I will draw this bond and this bond, and this bond is reshuffled. So in this way, this kind of product we get here. Sometimes this structure may be difficult, or there might be certain substituents present on the die, but you don't bother. You must focus on what? 6-membered ring. Your target is 6-membered ring. By just shuffling, by using these arrows, you can draw a 6-membered ring correctly. Don't worry, and you join remaining portion by just simply watching your substrates. You can join them properly and you will get the answer. That's it. Diels under reaction. Thank you.